Hello, my name is Elliot Walker, Program Coordinator of the Robotic WorX program.
And I'm Hunter Krabs, also Program Coordinator of the Robotic WorX program.
We've been getting a lot of questions lately about what Robotic WorX is. Today, we're going to try to answer them.
So to start off simple, what is Robotic WorX, Elliot?
Well, Robotic WorX is a joint venture between Millersville University and Precision Cobotics. Typically, manufacturing companies approach Precision Cobotics with production challenges in hopes of finding an automated solution. Precision Cobotics then outsources initial research and development to the Solutions Lab in Osborne Hall on Millersville University's campus.
And what happens in the Solutions Lab, Elliot?
Well, there, paid high school and college interns work alongside each other to develop and present an initial proof of concept. If the customer likes what they see, the project will move to Precision Cobotics' main facility in Lidditz. What does a typical project look like in the Solutions Lab?
At Robotics WorX and the Solutions Lab, no two projects are the same. Let's ask Lab Manager Ermias.
We work on things such as machine tending, bin picking applications, and also inspections as well. So some of the technology we have range from using URs to ABBs. And for our vision systems, we use mostly Cognex cameras, such as the 2D and 3D capabilities.
What's a UR and an ABB?
Yeah, so UR is a universal robot. They are collaborative robots, so they're designed to work alongside people. And this ABB right behind us is the IRB 1200, which is an industrial graded robot.
And what's the difference between a collaborative robot and an industrial robot?
Yeah, so collaborative robots are designed to work alongside people, while industrial robots do not have those safety features like the UR will have.
Okay, so what are the specific applications that you put these robots to in the Robotic WorX program?
Yeah, so one of our fun applications that we did was a picking application where we're using a Cognex camera to locate parts in a bin, and then from there it will communicate with the UR exactly on how to pick up the part.
What's a Cognex camera?
So a Cognex camera is an industrial graded camera that we use for things ranging from inspection. It can range from doing picking applications as well, like we just did, and also doing classifying. So it's using deep learning to also identify and doing classification of parts.
Is this the same sort of skills that students would be using in industry?
Yes, 100%. These skills are very easily translatable to any industry that they go in, especially in the manufacturing.
Is the camera just smart, or how does the camera communicate with the robot?
Yeah, so the way we're communicating with the UR is we're using Ethernet IP, and we're using something called Telnet, which is allowing this native communication between the Cognex and the UR.
Could you put that into like layman's terms for us, maybe?
Yeah, sure. So what we're doing is we're sending certain messages to the Cognex camera that it understands. For example, maybe sending a message such as GVB04 means get the value of a specific cell in the Cognex camera, and then from there the Cognex camera will then send that response back to the UR.
What type of engineering would this fall under?
Yeah, so this engineering is called automation robotics. Now we're going to show you some clips on things that we worked on the lab.
So yeah, I'm a high school intern. I'm working on this with a college intern. So essentially what this does is the robot will go down like to a point, pick it up with compressed air, and then move and just place it over here. Right now it's just super simple because we're just kind of messing around with which way of picking up the cardboard would be the best. Like we've done some like where the robotic arm is on an angle and slides up. And then we've done some where it puts pressure on this and slides over because the material of the cardboard is kind of like easy to like slide. So right now what we're doing, we've actually found that in this 3D printed piece there's a little lip here. And we found that the lip, sometimes the robotic arm picks up more than one piece of cardboard. And we found that the lip actually like knocks off the pieces of cardboard, like the extra pieces that are picked up. So I'll play this program right now and I'll run it a little bit slower just to. And in this specific program, we figured out how to get the robotic arm to move down by like interval like every time it goes down, because these cardboard pieces have a super small width, but over time they add up. So if you just had the robotic arm going down to the same waypoint every time, eventually it would start like missing pieces of paper. And a problem that we actually faced was we found like the Z negative value, and we tried to just like put the parameters into like the function that actually moves the robot down, and we had it moving down by 0.5 because like all the measures are in millimeters, and it like was failing. So then we tried to like, and we couldn't find anything about it. So we tried to make the value like smaller, and then just by like a stroke of luck, we moved the decimal point 3 places, and it worked perfectly. So like the parameter was taken in meters, and we were putting in 0.5 meters, so the robot was like going down way too far.
All right, Elliot. So what exactly makes Robotics WorX so unique?
Well, Robotic WorX is unique in that it lets high school students solve real-world problems in automation using industry-grade tools and equipment. The goal is to create a connection between the STEM skills that students are learning in school and what a real career in engineering looks like.
Participants in the Robotics WorX program not only learn about robotics and automation, but also valuable skills in teamwork, critical thinking, and problem solving.
So, I hope this answers some of your questions that you have about Robotic WorX.
And if you have any more, feel free to email us at robotic.works@millersville.edu.
Bye-bye.